Questions? Are there any? It was okay. This is my least favorite time of year, so it's the beginning of that season. Years ago, I was in a Walmart, and there was someone who was saying things that she really hated this time of year. And I said, yeah, right there with you. And then her mother, so this was a woman who was in her 20s, and her mother said, oh, no, she and her husband love this time of year, but her husband just got killed in Iraq. I thought, ooh, I don't know what she's going through. Anyway, on that cheerful note.
I did have another question. So on the it says homework quiz 9.
Yes.
Is it technically homework quiz 9 and 10?
Or
is it just 9? Because
that is
the master set combines the two. Because the master set's like 13 so questions.
It would be 9 and 10 then.
Indeed, so.
But we can make it just
9?
Well, I wrote up 9, we'll just make it 9.
So how does that work for the master set?
Master set would be, if 9 and 10 are combined, then it would be 9 and 10. Yes, I'm not going to ask you to pick out which problems are part of 9 and which are part of 10. So just do that.
Yeah.
I thought it said big count.
All right, other questions? All right, why don't we start out with, we're gonna head into the hallway. All right, so let's get some vocabulary down, some additional vocabulary. Amplitude. In essence, it's how big the wave is. Actually, that would be slightly more formal.
The length from the maximum to
Maximum to middle.
yeah.
Peak to median. And I can put distance in quotation marks because even though physically out there, that would be a distance from the maximum point to where the middle was, it's not always a distance. So sound can have an amplitude, but that would probably be in pressure or decibels or whatever you happen to be measuring, what aspect of sound you're measuring. Period. Time to produce one cycle of repeated, go ahead and throw. Yeah, no, motion does not need to be in quotation marks. Something has to be moving. Wavelength. The distance a wave moves in one period. There are other ways of defining wavelength, as in the length of a wave before it starts to repeat itself, but this, I think, works a little bit better. And then frequency.
How often something happens, a single cycle of repetitive motion occurs?
What he just said. Or with fewer words. I assume you happen to remember, or that's what you wrote down last time?
That's what I wrote down last time.
Okay, that's a better definition, so I don't feel like having to write it all over again. How often, how frequently? I should really use frequently, the definition of frequency. All right, anyway, the symbols used for period, the symbol is a capital T. The SI unit of period is, well, it's a time, so what would be the international standard?
Seconds.
Wavelength, the symbol is the lambda.
Upside down Y.
Or what's you can call it the drunk T. And it is wavelength. What would be the SI unit?
Meters.
And frequency. I use the same symbol as I use for friction. We're only in trouble if friction is creeping the wave.
Time or seconds?
Pardon?
For frequency, would it be seconds?
Not seconds.
Hertz.
It would be hertz, which is a reciprocal of a second.
So 1/over seconds.
And hertz is a capital H, lowercase c, not lowercase h.
Capital Z.
Or that either. That's the SI. Now, if you're looking at other sources, I don't think I talked about the nu, did I? If you look at other sources for frequency, they don't always use an F. Unfortunately, some textbooks will use the letter nu to represent frequency. The nu looks a lot like a V.
I used to think new was a word. Now it's a letter.
Nu is actually it's a triple homophone.
Awesome.
There are 3 nus.
View.
All right, so the letter nu, when I draw it, typically looks like that. Well, it's kind of like a V.
Drop the V.
Or a V caught in a windstorm.
Or it's repeated.
Now, in some fonts, the nu looks like that, which will seem more like a V. Actually, in the fonts where the nu looks like that, the V looks more like that. And in ones where that's the nu, V looks more like that. So it can get very confusing as you're looking at an equation. Now, if there's an equation that involves speed and frequency, it would cause some issues. And there is. So, V, speed. What's the formula for speed?
Distance over time.
All right. So if we think about a wave that's being created, and we think about a single wave, what is the distance a single wave is going to travel in, let's just say, a period?
Distance.
Yeah, what is the distance that it travels in, if the time is a period?
So
It'd be the whole, I guess, wavelength?
Yes, it is the wavelength, which is the distance a wave moves in one period. So we have a formula here for the speed of a wave, which is wavelength divided by period. Now, period is the time to produce one cycle, so that is seconds per cycle. And this is, I think, a repeat of what we did last time. So this would be, say, seconds per cycle, or some unit of time per cycle. It's not always seconds per cycle in terms of convenience. The Earth goes around the sun. It's 1 year per cycle. Frequency is just the reciprocal of that. So frequency, how often the cycles are created. In other words, it's cycles per unit of time. What I'm getting towards here is that, well, that's just lambda times 1 over the period, which is lambda times the frequency. So we have an equation here. Now, if you're looking at a source which is using the letter nu for frequency, it will look like this. Or
yeah, just a quick question. When you're drawing the lambda, is the if you draw it like a drunk torque, for example,
a drunk tau.
the drunk tau, does that work as well?
Kind of like that?
Yeah.
Yeah, that works.
Just make sure you know what I'm drawing here.
All right, so if you run across a source that is using the nu for frequency, look for this equation. That will tell you what the fonts they're using are. I mean, not specifically, you can't look at it and go, oh, that's Times Old Roman. What you do is you look, that's going to be the V, and this will be the nu. So hopefully, this is the last time nu comes up. And nu, by the way, is spelled N-U, not N-E-W or G-N-U.
Are most of like the things you do in one specific thing? Like if we have a problem on like a master set or a quiz?
It should always be an F for frequency.
Okay.
Yeah. The only time like potentially inconsistent is the subscript for initial, say initial velocity. Sometimes they'll use an O or a 0 or an I. I think I've settled upon I, but there might be some older sources that do it differently. All right, questions to hear? Any objections if I erase this?
So are we gonna have like kinematic frequency equations?
Kinematic frequency equations. Well, I would say yes. Perhaps not the way you're thinking of right now. Okay. Patience. Patience. Got it. Patience. So if I'm talking about two fixed ends, well, first off, a fixed end is a node. So whatever wave I'm about to draw, if it's two fixed ends, I'm going to have a node at each end. This would be the simplest form. This is the first harmonic. If this distance here is L, what is the wavelength?
1 or L?
It is not. What does a full wave look like?
There and that. So L times 2.
A full wave looks like that. Or if I drill it as sort of a harmonic like that. This is a half of a wave. So L is equal to a half of a wave. So the wavelength would be 2 times L. The second harmonic, well, there should be symmetry there. This is the second harmonic. many wavelengths is this?
4. 2. 6.
Wrong way.
Would it be 1?
It would be 1. One wave. That's one wave right there. I just put it on its side. So in this case, L would be equal to 1 wavelength, or the wavelength is just equal to L. Next harmonic. That's the third harmonic. How many waves is that?
1.5.
So L is equal to 3/2 of a wavelength, or the wavelength is equal to 2/3 of L. Which makes some sense there, that if that whole thing right there is L, and that is a wave right there, well, that's 2/3 of the overall thing. So. And what the heck? Let's go for the fourth harmonic.
So it's not 2/3, or it's not just 1.5 waves. It's just 2/3. Because in my brain, if we have the second one, that's just 1, and we add one more thing, it would be 1.5.
Yeah, well, that's I wrote it as a fraction here. Would you prefer L is equal to 1.5 wavelengths?
Yeah. Okay.
In which case the wavelength is equal to L divided by 1.5. These are identical. That's right there.
Is that not 2/3?
What?
Which is 0.66 instead of 1.
1.5 is 3/2.
Yes.
Okay.
The one right below it is 2/3.
That's 2/3, which
Yeah.
is 1 divided by 1.5. There's confusion there.
Yeah.
Don't try again.
2/3 is 0.66.
Yeah, repeating.
Maybe I'm just mathing wrong.
They are all saying the exact same thing.
Yeah.
Okay.
Okay.
Okay. Pick the one you like.
Mm.
Fourth harmonic is going to be how many wavelengths?
2.
Yeah. What's the pattern?
It's increasing.
So no matter whether we're doing 2 fixed and a free end, or 2 free ends, every time you go to the next harmonic, you add half of a wave. So if you drew it, and again, they're all supposed to be the same size. The more loops I put in there, the less it's going to look right in terms of my artistic skills. So I guess maybe that's the reason I'm not an artist.
So you lied to it?
Yeah. See, yeah, that's not big.
Now, another pattern here. This is a half of a wavelength. This is 2/2 of a wavelength. This is 3/2 of a wavelength, and this is 4/2 of a wavelength. Nothing magic there. You look at the numerator. First harmonic, second harmonic, third harmonic, fourth harmonic. It's 4 times whatever the first one is. That's 2 times whatever the first one is. That's 3 times whatever the first one is. And the reason I bring this up is that when we do the 1 fixed, 1 free, there is no second harmonic. But we'll get there.
So the pattern there is that the numerator reflects the harmonic.
Yes. Given that the denominator is whatever it is for the first one. Now, some textbooks, and I can't remember what yours does, some textbooks will give a list of equations about determining the length or the wavelength for a particular situation. I never remember those. Just set up the pattern. Once you get the first one done, then you know it's just going to be a multiple. So if it's the third harmonic, well, it's L is equal to 3 times whatever the first one is. All right, questions? I'll leave that up for posterity and we'll do it over here. All right, one fixed, one free. So a fixed end, node or antinode?
No.
Free end.
No.
Anti.
Let's use the proper language.
Anti.
And again, nodes are the points which are not moving, antinodes move the most. So one fixed, one free. The simplest form we can do is like that. This is the first harmonic. How many waves is this? If this is L.
The wave's like broken in half.
Would be half. Because
It is not a half.
One there with one.
I heard somebody say it, I think.
it said 1/4.
It is 1/4.
What is wrong? Oh, that's one half. That has to be a quarter.
Yeah, if you think about it, starting here, I only have to go to that point right there. It's just a quarter of it. So the wavelength is 4 times whatever that length is. The next one, how many waves am I going to add every time I go to the next harmonic? Yep. So the next simple